not something new. You worked with asymptotes a lot in the advanced functions course. That's why to start off, we are going to remember what we know about them. Okay. First of all, I want to ask you, what types of asymptotes do you remember? Omar, Ismail.
Vertical and horizontal.
Okay, that was not
Miss,
Omar.
can you repeat the question because it was lagging?
So the types of asymptotes were, and someone answered vertical asymptote and horizontal asymptote, but those are not the only ones. There is one more.
Oblique asymptote.
Oblique asymptote. Okay. So, and we will go one by one, and we'll remember how to know if the function has got this or that asymptote. Okay. Let's start with the one which you're most familiar with, which is the vertical asymptote. And I want to ask you if you can remember how to know whether there is a vertical asymptote in the function or not.
For the denominator, if we cancel the denominator, then it's like a vertical asymptote.
Any other ideas other than this one?
For the denominator to have one more, power more than the numerator.
If the denominator has got one power more than numerator, this is related to vertical asymptote. Okay, so guys, stop taking notes because big part of curve sketching in calculus is based on your prior experience in advanced functions. So consider it as a review. So the vertical asymptote, I didn't hear anything reasonable till moment. Last chance. So how to know if there is a vertical asymptote in a function?
A vertical asymptote occurs at the number that makes the denominator equal to 0.
Absolutely. So in other words, vertical asymptotes are zeros of denominator. Okay, which means that what type of functions is it relevant to?
Rational.
Only rational, right? If there is no denominator, then there's nothing to talk about. Absolutely. So, but there is a small like twist here, right? So to say it's all the zeros of the denominator will not be very accurate. Who remembers that there is a small trick there? Let's talk about specific examples. So for example, if I have x plus 3 over x minus 5. So Noor Gineji, what can you say about this function? Does it have a vertical asymptote or no?
Yes.
So where is it?
At 5.
And how do we state the vertical asymptote?
Can you say that again?
How to state the vertical asymptote? How should it look like? You just say at 5, will this be enough?
No, miss, at
What
x
is-
equals 5.
So x equals 5. So the vertical asymptote is a straight line. That's why it's represented by an equation. That's why in terms of communication, it has to be always written as an equation. X equals and then the value of the zero of the denominator. In this case, it's 5. Okay, this is, I hope, clear.
Hi, Miss Natalia. I'm here with Mayugi.
Good. So let me give you another example. What if I have a function which looks like this? Okay, so what can you say about this function in terms of vertical asymptote?
It has a hole.
So it does not have a vertical asymptote, but it has a hole. How did you know, Farida, that there is a hole?
We cancelled out.
Cancelled out what?
Because the
X minus 5 was the X minus 5.
Yeah, so when we cancelled
There's a hole.
the factor, yeah, which contains the zero of denominator, right?
Yes.
So there is a hole at x equals 5. Then going back to the vertical asymptote, how can we make this statement more accurate? So vertical asymptote, basically zeros of denominator, and then let's add something to show that we took this case into consideration. How would we formulate it? Farida, zeros of denominators, of the denominator of which?
I don't know, like haven't been crossed out.
After it's simplified?
Which can't be cancelled, right? Which can't be cancelled. Cancelled out. Or like you understand that now when I have done this step, how does the function look like algebraically? It looks like this. So you don't see the zero of denominator anymore there. So the zeros of denominator which can't be cancelled out. Also, I want to grab the opportunity to master your sketching skills. That's why I want to ask you. So if you know that the function looks like this originally, and now it looks like this, and with this information in mind, how will the sketch of this function look like? How can we sketch
It will ماشي قولي.
Anybody?
Going to be a line that intercepts the y-axis at 3, and it increases, and there's a hole.
Where does at 3, right?
Yes.
3, okay. And
it increases, and there's gonna be a hole at 5.
And they're going to be a hole at 5. Very good. So, and what is the slope?
1 over 1, so like right over run 1, 1.
So the slope is 1, right?
Yeah.
Okay, so something like that. Where if this is 5, then at 5, it has an open dot, which is the graphical representation of a hole on the graph, okay? So this is the difference between this function and if you just had a function from the beginning, y equals x plus 3, right? If it was just like this from the very beginning, it would have been the same straight line without a hole. But since originally this function used to be rational function, so we have to take this into consideration. Right. That was vertical asymptote. So let's remember the second type of the asymptote, which you mentioned, which is the horizontal asymptote. Okay. So anything that you have to say about it? What do you know about horizontal asymptote? How do you know that
it has to do with like the power of the numerator in comparison to the power of the denominator.
Let's start with the way it looks. How does the equation of the horizontal asymptote start? What does it start with? If it's a horizontal line. This one used to be x equals something.
Y equals.
So the horizontal asymptote is y equals something, right? Good. And something means a constant, right? A specific value. So let's now remember the cases from advanced functions. So for example, if I have a function, okay, example 1. If I have a function like that. Okay, what can you say about the horizontal asymptote in this function? Guys, who remembers?
-3.
Are you sure that you are not talking about vertical asymptote?
Miss 5. 5.
5. So the equation of the horizontal asymptote here is 5. Can you explain how do you know?
I remember that we used to look at the variable, and it's 5/1. And if it's x,
Exactly. Leading coefficient
the leading
and
coefficient.
yes, leading coefficients of the variables. So, but there is a condition. What do we know? What kind of condition should be there?
Is it that the exponent, like for x, has to be the same for the numerator and the denominator?
What is x has to be the same? What do you mean exactly?
The exponent.
The degree, right? Okay,
Degree,
so
yeah.
or the exponent. So when the degree of numerator
Miss
and
Abdullah is telling you
denominator.
that his internet is not working.
Who is saying this?
Abdullah.
Abdul's internet is not working. Okay. When the degree of numerator and denominator is the same, which means that it doesn't have to be linear. For example, if they both quadratic or whatever, this pattern is still there. Okay.
So what if one was power 2 and the other is
We're going to discuss it. So let's
to be an
look
oblique
at
asymptote.
yeah, صح. Yes.
right away. What about the case like this? Who remembers? What can you say about the degree of the numerator versus the degree of the denominator?
It's less.
It's less. So when the degree of the numerator is less than the degree of the denominator, there is another pattern. While you're thinking, I'll write it down here. Think, please. When the degree of numerator is less than the degree of denominator. Any ideas? Noor Fahmi, do you have ideas?
I think it's gonna be like y equals 0, because that was the
Yes.
most common case.
Yes, y equals 0. Whenever
Miss,
the
I
degree of the
didn't
numerator is
understand
less,
why equals 0.
it's not y, it's a pattern which we were discussing in advanced functions. But y is the question for today, by the way. Because today we will figure this out, we'll learn how to figure this out, these values of the, which will correspond to the horizontal asymptote using the limit. But generally, you understand, Mina, there is a pattern, right? So one of the patterns which was discovered for the rational function is whenever the degree of numerator is less than the degree of the denominator, this function will always have a horizontal asymptote at y equals 0.
Oh,
I
okay.
can give you another example. Another example I want to, so that you see clearly that the cases of this pattern can be different. So another example will be like this. What can, look at this one.
Yes,
What is
the degree of the
numerator? What is the degree of the
numerator
numerator?
is 0.
Yes,
0.
and denominator
1.
1. So it's less. So if you just
Yes.
go to Desmos and input it, you will see that the horizontal asymptote is also y equals 0. Okay.
Okay. Oh, okay.
All right. So those are the cases which we used to know about horizontal asymptote from the advanced functions. Yeah, the important thing is when you sketch, okay, when you used to sketch this kind of functions, you used to explore the behavior of the function around horizontal asymptote, because manual sketches that you don't know how it looks, right? So you need to do some kind of analysis in order to figure out how it looks. So who remembers algebraically what can I do in order to know how the function is approaching horizontal asymptote. I'm getting ready to sketch this function, the first one, 5x minus 2 over x plus 3. So it's a function which has a vertical asymptote at -3. While you're thinking, again, my question was, what should I do in order to understand how the function what's the function's behavior in the region of the horizontal asymptote? So think 1 minute while I'm just preparing.
Miss, don't we take a small,
Yes, Abdurrahman.
a very small number and then a very large number, and we input it, and then we know if it's positive or negative approaching the.
You are on the right track, I think, but not. What is a very small number? You mean what? Like what? What do you call a small number? Something close to 0 or something very
like
negative?
Negative values, because we're looking at the left and the right side of the asymptote.
Absolutely. Yes, absolutely. So what we are doing, we're basically, yes, good. So we're basically checking, okay, if I go to the right, very far to the right for x, and if I go very far to the left for x, what will happen to the curve? Is it going to, although I know that the horizontal asymptote is y equals 5, this is not enough to sketch, right? Because it might approach the horizontal asymptote from above, from below, right? So this is what I need to figure out. Yeah. So let's do what Abdurrahman said. So guys, you will need the calculators now. As I said, we are working with this function, okay? We're making a very rough sketch of this function. So we are checking if x approaches positive infinity and if x approaches negative infinity, what does the function do? So,
Miss Natalia,
yeah.
as x approaches negative infinity, it approaches like the 5 from above.
Tell me the value. So you already did the f of -1000 or something
Yes.
like that. So what is f of negative? So I need someone to do f of positive 1000. Who can do it?
It's 5.002 for the negative.
5 point. Okay.
For the positive, it's 4.98.
4.98, and for the for the negative, you said what?
5.02.
Exactly. Okay. Good. Let's make conclusion. So when I go to the right, is the function approaching the asymptote from above or from below?
Below.
From below. So it means that it looks like this, right? And if x approaches negative infinity, is the function approaching horizontal asymptote from above or from below?
Above.
From above. So it's like this. Okay. So this is much better. Like based on this, can already
Okay.
I think I'll take a break now because yeah, suddenly I need to drink something. So something like that, right? I just want to reach the conclusion before I lost your focus. So in this course, we're going to basically follow the same logic, which means that we will set x approaching positive infinity or negative infinity. But you know that in calculus we have different tools. For example, limits. So this is what we're going to do. Can you see my presentation?
Yes.
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 Okay, so this is what we're going to do. We will be looking for a limit of the function as x approaches infinity, positive and negative infinity. In fact, we'll do only infinity and that's it. You will understand eventually why. So, and then the value of that limit will be exactly the horizontal asymptote. Okay. So with the oblique asymptote, there is nothing new. So I want to jump into horizontal asymptote right away because this is the only new part, and this is the only part of the curve sketching algorithm where we're going to apply calculus tools, in particular limit. So we will look, before we look into an example how to figure out whether there is a horizontal asymptote in the function or not using the limit. I want you to, if you want, you can write it down. This is very important concept. Remember the limit, right? What is the key word about the limit? Like a synonym of the limit, or how to describe what limit is. Abdurrahman, you used to be the one who was always remembering this word. I remember. Nobody else. Abdurrahman.
As it
Yes,
approaches.
miss, your voice was cracking. I didn't hear.
So the question is, limits. What is limit exploring? Paul, what is the word which describes the limit? Approach. Yeah. Okay.
Yes,
Based on this, think about it. If I have forget about functions and calculus, just think about common sense in math. If I have a fraction, and in the fraction I have 1 in the numerator, and in the denominator I have very large number. Right? This is what x approaches positive infinity means. It means that instead of x, I can input any large number. So if you divide 1 by any large number, what will be the value of this fraction?
Decimal.
It will be decimal, but it will be decimal which will be
before
very close to
zero.
which value? It will be very
Zero.
close to 0. So it will be something
Okay.
like 1 over a million, for example, right? What is 1
Yes.
over a million? It's 0 point and then 0, 0, 0, 0, 0, and so on. The same with the negative. So whenever you set the denominator in a ratio, approach something very big, whether positive or negative, the ratio will approach 0. And since it will approach 0, this is where limit comes, right? The limit is the different way to say that it's approaching it. Okay, so bottom line, also there is a graphical interpretation of this. If you remember, 1 over x is the parent function for rational functions. So in fact, if we just do the same process like what we have discussed now, if I go to the right and to the left for x, I see that the curve is sticking to the x-axis. What is the equation of the x-axis, guys? Mathematical equation for the x-axis.
X no. X
No.
equal.
Y
Y
No.
equal.
zero.
Y equals what?
0.
Y equals 0. Okay, so basically for this function, the horizontal asymptote is y equals 0, which is exactly the same thing as x-axis. Okay, so both ways we can, I hope you're convinced that whenever you are dealing with a ratio where in the numerator it's 1 or any other constant, and in the denominator you have a very large number, then the limit of this kind of quotient is going to be equal to 0. This is the key idea which is going to be used in limit evaluation when it comes to horizontal asymptotes. And this is what I'm going to show you right now in one of the examples in the textbook, and then we'll do another example together, okay? So example, then a break, and then example together. Page 185. Example 3. Okay, so you have various functions here. All of them are rational. And you're asked to define the value of each of the following, which is the limit. But I want you to be mindful of, again, this idea that finding the limit when x approaches positive and negative infinity means finding the horizontal asymptote, right? And if you remember this, then it's easy for you to even anticipate the value of the limit before you even get it algebraically. Let's try, let's test it. Can you anticipate what was going to be the value of this limit before you started doing the steps? What is the value of this limit if you know that the limit of this function as x approaches infinity is going to be the same exactly value as the horizontal asymptote?
Is it going to be 2?
Yes. How did you know? Explain.
Because I did 2 over 1. Because that's the
Exactly.
coefficient of the axis.
And it's the case when the degrees are the same, right? Okay. What about b? Guys, what is going to be the value of this limit?
0.
0. And guys, what about this one?
2 over 3.
2 over 3. So you can anticipate, but in your assignment, when you do the curve sketching, when you analyze the horizontal asymptote, you will have to use the limit as a tool. Okay. How? You will see it right now in this example. So let's take the first function, 2x minus 3 over x plus 1. We will rearrange the function in a specific way, which will allow us to evaluate the limit. The trick which works here and in all the other functions is to factor out the greatest power of x, always, from the numerator and from the denominator. So if you just remember this thing, you will be always on the safe side. Okay? What is the greatest power of x in the numerator?
X.
2x is the power. I'm asking
1.
about the power of x. 1. So it means that, okay, you can, 2 is not important. You can factor it, you can keep it. Not important. What's important is that you are factoring out the greatest power of x. In this case, it's the first power. So 2x is out. This is the leftover. Do you have questions about the leftover in the numerator inside the brackets?
No.
The same down, okay? So we do the same thing also because in the denominator, the greatest power is first. So I factor out. When I did this step, I can cancel out x and x, right? So I'll be left only with 2 times this expression and the denominator like this. So now this function is ready for us to apply the limit. So in this step, I'm going to evaluate the limit of the function. This is probably the only time in our course when the properties of the limit are very helpful. So if you remember, to find the limit of a fraction or a quotient is the same as finding the limit separately of the numerator and denominator. That's why you see that they wrote limit at the top and at the bottom, because this is one of the properties of limit, that yes, I can do this. Now 2 is out. Why 2 is out is because it's like derivative. If you have a constant coefficient, you can just take it out, like factor it out, and that's it. You don't need to put it under the limit sign or under the derivative sign, okay? The most interesting part is this one. Okay, so to evaluate the limit of this difference, I also think about it that, okay, I can evaluate the limit of each term in the difference separately. What is the limit of 1? Guys, what is the limit of 1? Nobody remembers, right? Okay. So if you don't remember, I also don't memorize anything, but I always sketch, okay? So if I have a function 1, as a function, it will look as y equals 1. How does it look? How does the graph
So the
of
limit
this
is 0?
is what?
Is 0? Because the slope
You're
is 0.
in a hurry. You're in a hurry, no.
To be a
So
horizontal line at 1.
which cuts
Yes.
the y-axis at 1, right? This is how
Yes.
it looks. Now Nur Ginedi will tell me if I want to find the limit of this function as x approaches infinity. So if I go to the right, Nur, to the right and to the right and to the right and to the right, what will the function approach?
1, right?
1. And if I go to the left, what will it approach?
1.
Also 1. So the constant functions will always approach the same value, okay?
Okay.
So let's go back. So it means that the limit of this term is 1. Here it is. Now think about this one. This is exactly what I mentioned on the slide. I have a constant, and down x approaches infinity, right? Because you can rewrite it separately as limit of 3 over 2x as x approaches infinity. Let me write it down to make sure that you don't just say yes, it's clear, and then you don't understand anything. 3 over 2x as x approaches infinity. So let's think about it. This is 3. This is 2 times infinity. What do you think will happen if you multiply infinity by 2? It's like fundamental philosophical questions, I would say. What will
Is it
happen if you
going to be
multiply?
infinity also?
It will be also infinity, right? Like, because it's infinity, so you can
Yes.
multiply it by whatever, it will be an infinity. Very good. So I can basically disregard this, right? So basically what I have, a constant over, I don't want to write the equal sign here because it's not precise. I just want to take it separately and talk about it, think about it. So think about the fraction 3 over infinity, which means 3 over a million, 3 over 10 millions. What will you get approximately?
0.
0, right? Although it's not 1, but common sense, if you divide a constant by something infinitely large, the quotient will approach, it will not be exactly equal, but it will approach 0. And since it will approach, this is what the limit is. Going back to the example, we can say that this is 0, as well as this is 0, right? So this is where you can see them, and then you do the simple calculations, and you get 2, which is exactly the same value of the limit as we anticipated from the beginning, that 2 is going to be the horizontal asymptote. Do you have any questions about the steps? If not, I'll just go through another one quickly. And to highlight again, here, for example, they are different powers, right? The numerator and denominator, they are different powers. Doesn't change anything. Still, the trick is the same. Factor out the greatest power of x, or whatever variable you have, from both numerator and denominator. So if they are different, then act differently. So here is the first power. Here is the second power. So when you did this, you can cancel one of the x's, right? So you have x only down, and then you work with this part. So the limit of x will stay separately like this as x approaches infinity. This is the limit of 1 is 1, and this is 0. So it means that all of this is 1, okay? And then since the limit of x is, or as x approaches infinity, is infinity, so you can rewrite it like this. And when you rewrite it like this, you already know that the limit of 1 over infinity is 0, which was exactly our anticipation about the horizontal asymptote. Okay?
Take a
That's
break,
it. We're going to
guys.
practice now. A question?
No, I'm telling you to take a break.
Ah,
For you, yeah.
for me?